This is Unit 1, Transformations, and the topic is Transformations. Okay, so this is a review from last year. This is going to go over all the types of transformations that we will see applied to our parent functions. Now, they are the same as last year, but the vocabulary is a little different. So for this first column, we have vertical translation. This is the same as what you did for up and down last year. Now, the only difference is that we're going to focus on the value that we use, whether it's positive versus negative, and that tells us whether it will be up or down. Now, how the problems will be presented to you is that they will say vertical translation, so you have to focus on the k value. So if k is greater than 0, that's going to be up. If k is less than 0, that will be down. And then this shows that we have f of x minus 2, which means we are going to shift our graph down. So all points will be shifted down too, but everything else will stay the same. Oh, wait a minute, this picture's off. So we see that it's 2 here, all the way up until here. This should keep going. This should go up. Oh, I did not catch that in class. Okay, so this picture is wrong. So from here, see how this has a slope of 3? This only has a slope of 2 down here. That should have a slope of 3. So we should be going up to here, and then it extends. Okay, so that part should not be there. There we go. So that's what it should look like. Interesting. Okay, the next one is a horizontal translation. This is your left and right. So remember, anything inside of the parentheses is going to be the opposite. The reason why this happens is because when you apply transformations to the input, it's like you're undoing the transformation. So you have to use the opposite for the h, and then it'll be another case for the horizontal dilation. So for this one, a horizontal translation, if your h value is less than 0, that means your translation is going to the right. If your h is greater than 0, then it is going to the left. So if we look at the sketch down here, we have f of x plus 2, which means it is going to shift to the left, or it has a horizontal translation of -2 units, which means it infers that it is being translated to the left. The next one is our vertical dilation. Again, this is your compression and stretch, but now there's an umbrella term which is going to be dilation. And again, this is on the outside of the f of the function, so it's going to change the y values. So if your a value is between 0 and 1, that means it is going to be a compression. If your a value is greater than 1, that is going to be a stretch. And I put these in quotations because you will not see these terms, unless it's from old material that we're using, but College Board uses dilation, which is what you'll see on the AP exam as well. Now, if we look at this, we have a -2 here, all right? This is 2 separate transformations. It's being reflected over the x-axis, and it has a vertical dilation of 2. Okay, so those are 2 separate transformations. Lastly, we have a horizontal dilation. Remember, it's inside the parentheses, so it's affecting the x values, which means we have to apply the reciprocal here. Okay, so if b is in between 0 and 1, that means it is a horizontal stretch. If b is greater than 1, that means we have a horizontal compression. And if we look down here at the example, we don't have a horizontal dilation here, we just have a horizontal reflection, or it's being reflected over the y-axis because that negative is inside. It's reflecting the x values. All right, so that was a quick review. This is a AP classroom question. Let g be a function that is a transformation of the function f such that g of x is equal to 2 times f of x minus 3 plus 1. Describe the transformations of the function f that result with the function g. So reading left to right, we have 1, 2, three transformations. The first one is going to be a vertical dilation with a scale factor of 2. Okay, so again, I'm not using stretch or compression, it's going to be dilation. If you say vertical stretch with a factor of 2, you'll get credit, but they're going to write this out to you as a dilation, so the quicker that you become familiar with these terms, the easier it's going to be for you later, especially when we get to trig later. All right, the second one is going to be it's inside the parentheses, so it's affecting the x values. So it's going to be a horizontal translation of 3. So again, I'm not saying right or left. You could say right and you would get credit, but I'm going to determine which direction it is translating based on the numerical value. It is positive 3, so it is going to be moving to the right 3. So it's going to be the opposite of what you see in your transformation map or your function. The last one is going to be a vertical dilation of positive 1. And again, because the 1 is positive, that means it is going up. The next question, let n be a function that is a transformation. So they're going to go back and forth. Oh, nope, they both say transformation. Transformation of the function m such that n of x is equal to negative 4m of 2x. Describe the transformations of the function m that result with the function n. mn, that's confusing. So off the bat, well, in class at least, a lot of people thought this was only 2 transformations. We have 3. We have that negative, we have the 4, and we have the 2. So we have 3 separate transformations occurring. So the first one is going to be reflected. That negative is on the outside, so it's changing the y values. So whatever y values are positive, they are now going to be reflected and become negative. I don't think I did that right. So yeah, it gets closer, further away, and then so close, far, and then close. There we go. So it's reflected over the x-axis. The next one is the 4. It's a vertical dilation by a factor of 4. By a factor of 4. And on the inside, we have a horizontal dilation. Now, if you look back at the notes, in order to get the scale factor, your b value is what is inside of the function. You're going to use the reciprocal, so it's going to become your denominator. So the scale factor is going to be 1/2. And this is convenient because these are the values that are going to go in your transformation table, okay? All right, next here we have a graph. The graph of y equals f of x consisting of 2 line segments and a semicircle is shown for -3, which is less than or equal to x, which is less than or equal to 5. Sketch a graph of g on the same axis where g of x is equal to f of x plus 3 minus 4. Okay, so we have 2 transformations. We have a horizontal translation of -3. And then we have a vertical dilation, sorry, not a vertical dilation, a vertical translation of -4. So for each, I'm going to call them key points for this piecewise. For each key point, it's going to be shifted 3 to the left and then 4 down. And I'm going to say that my major key points are going to be these right here. Because as long as I can sketch these, then I can sketch the rest of the line segments. So with this one, I'm going to go over 3 and then down 4. And I have the first part. Now you can do the same thing, or you can use the geometric shapes that you're seeing. That's part of why they say it's two line segments and a semicircle. Right here, I can clearly see that I'm going down 2 and over 3. So I'm going to do the same thing over here. Down 2, over 3. Let me get rid of those lines. So down 2, over 3, and then I can connect that line segment. Next is the semicircle. I'm going to come back to this, but I can see that the radius of this semicircle is 1/2, or the diameter is 3. So I'm going to travel over 3, 1, 2, 3, oops, and put the next key point there. And then I can see I have a line segment that has a length of 2 units, so I'll do that. Now don't just throw in any random semicircle. We know the diameter is 3, therefore the radius is going to be 1/2. So I'm going to travel in 1/2, and then go up 1/2. That way I can draw an accurate semicircle here. And then there is our generic function. Oops. So 1/2 will be here. Our transform generic function. They didn't ask for the descriptors, but it doesn't hurt to practice the vocabulary. All right, example 4. The graph of y equals h of x has a hole at x equals 4 and consists of the 3 linear segments. Sketch a graph of k on the same axis where k of x is equal to negative h of 2x plus 1. Okay, I'm going to approach this a little bit differently. Because we have a vertical reflection and we have a horizontal dilation, I'm going to use a transformation table. It's not required, but it is good practice because on the assessments, we will ask you to use a transformation table. So get the practice in as much as you can. The key points I'm going to be using are here, here, this. I'm going to utilize the discontinuity here, the removable discontinuity. You utilize this point and then also this point. So the first point is going to be at -4, and then what is that? -3, this one here. My next point is going to be at -2, +1. This point is at 0, -2. The whole, that is going to be at 4, 2. And I'm going to label that because I don't want to misrepresent it after I apply the transformations. And then I have my point, so I'll call that point. That's going to be at 4, -1. And then the end of that last line segment is going to be 6, 4. All right, so the transformations that we are applying to the x values, it's just that horizontal dilation. So the b value is equal to 2, therefore the scale factor is going to be 1/2. And now we just multiply all of these values with that 1/2 to apply the transformation. So 1/2 times -4, -2, we get -1, 0, 2, 2, 3. For the y values, we're going to apply this reflection, and we have a vertical dilation of +1. So I have -y plus 1. So -3, we're going to negate that, which gives us a 3, and then we're going to add 1, so we get 4. Now we have -1, so -1 plus 1, we get 0. Negate the -2, we get +2 plus 1, so that's 3. Negate the 2, we get -2 plus 1, so we get -1. And then 1 plus 1 is 2, -4 plus 1 is -3. All right, from here, we can go ahead and sketch these points. So the first part of the first line segment is -2, +4. Next, we have -1, 0, and then I'm going to go ahead and connect them, just so I don't get confused. Whoops. The next one is going to be 0, 3, and then we'll go ahead and connect them. All right, now I have the location for the hole. It is going to be 2, -1. 2, -1, and then I'm going to go ahead and connect that line segment. I'm just following what the previous one was doing. And then I have the point, which is at 2, 2. So 2, 2. And then completing that third line segment is going to be at 3, -3. Should be the same slope as before the hole. And there we go. So again, it did not require a transformation table, but it helped me to keep my data organized. All right, next we're going to be looking at a table. Oh, on the AP exam, you will never be asked to sketch. However, in the course here, you will be. So on your unit test that we have in our course throughout the year, we will be asking you to sketch. But once you get to the AP exam, they will not require you to do that. But I think it helps to be able to sketch these ideas out because it helps you understand what's happening a little bit more. Next, we're going to have a table. So the table above gives values for a function p as selected values of x. Let h of x equal 3 times p of 2x minus 1. Find the following values. Okay, the first thing that we see is h of negative 1, which means, I don't want to use this color, which means that x is equal to negative 1. That is our input. So that's where we're going to start. So if I use this map that they gave me, they're telling me that x is equal to negative 1. So whatever this is, that's what the x is going to become in our function. So let's see. So I have 3p of 2 times negative 1 minus 1. All right, from here, just simplify. We have 3p, 2 times negative 1 is negative 1 minus 1. So the misconception, this is from teaching it in class today, is I saw people doing 3 times p times negative 1. This is not true. P is a function, all right? So what we're looking at here is p of negative 1. This is one term, all right? It's exactly like this. We have an input and we're plugging it into h. For this one, we have an input and we are plugging it into p. And the information for p is in the table, all right? So I have p of x here, the output for whatever the input is, which is x. In this case, the input is negative 1, so I'm going to look for where, oh, negative 2, yikes. Can't multiply. So that should be negative 2. So I want to find which column has x, or the input as negative 2. That's going to be this first one here. So when x is negative 2, for p, the output is going to be 1. So p of negative 2 is equal to 1. So I have 3 times 1 minus 1, which means the answer for h of negative 1 is going to be 2. All right, same process for 2. X is equal to 2. That is our input. So we will have 3 times p of 2 times 2 minus 1, which equals 3 times p of 4 minus 1. So now my input for the function p is 4. And if I look on this table, the output is going to be 3. So now I have 3 times 3 minus 1, which is going to give me 8. And lastly, for part C, x is equal to 0. So now we'll do the same process. We have 3 times p of 2 times 0 minus 1. So we have 3 times p of 0 minus 1. P of 0, the output for when x is 0 for the function p is going to be negative 1. So we have 3 times negative 1 minus 1, which is equal to negative 4. So this is pretty basic for AP pre-calculus, is that you're going to have 3 ways of demonstrating that you understand a concept. You're going to have describing it, you're going to have graphically, and then you're going to have a table. And then obviously, like within all of these, analytically. All right, last one for this topic. The table above gives values for a function h at selected values of x. Let k of x equal a times h of b times x plus c, where a, b, and c are positive constants. In the xy plane, the graph of k is constructed by applying 3 transformations to the graph of h in this order: a horizontal dilation by a factor of 1/2, a vertical dilation by a factor of 3, and the vertical translation by 1 unit. Find the value of k of negative x. So this is a combination of what we did in the previous few examples. The first thing I want to do is identify my variables, my ABCs. So I need to identify my A, my B, and my C. In this case, my A value is going to be my vertical dilation. All right, so if I look here, they tell me that it has a vertical dilation by a factor of 3. My B value, that's going to be my horizontal dilation, but you have to keep in mind that your horizontal dilation is going to be the absolute value of 1 over B. So we want to take the reciprocal of whatever that scale factor is. The horizontal dilation is by a factor of 1/2. Therefore, my B value is going to be 2 over 1, which reduces to 2. For our C, it's a vertical translation by 1. That 1 is positive, so I'll just keep it positive. So when we plug these in, we have K of X is equal to, my A value is 3, and then H is the function. We are not changing that. That is just our function. And then B is going to be 2, and then we have our input X, and then plus 1. So now we're changing the input. The input is no longer X, it is now -6. So you have to start a new equation. So K of -6 is equal to 3H of 2 times -6 plus 1. We end up with 3H of -12 plus 1. So again, H is a function and -12 is the input. So we need to use the table to find the output, which is going to be 1. So that means 3 times 1 plus 1 is equal to 4. All right, I hope this helps. Thanks.